So what if we've been training AI all wrong? I mean, what if the key isn't just throwing more and more data at it, but actually using smarter data? Today, we're diving into some fascinating research that explores just that. Let's get into it. Okay, I want you to remember this number, 150 times. Just keep that in your head. It's the key to this entire story, and it represents a massive leap forward in how we can train AI. Because that's the big question here. How is it even possible to get a top-tier AI model with 150 times less data? I know, it sounds kind of crazy, but it all comes down to a totally different way of thinking about the data we're feeding these things.
But, to really appreciate why using less data is such a game changer, we first have to talk about why the whole industry has been obsessed with using more. For years, the mantra in AI has always been more is more. See, all these amazing AI models we use every day, they rely on something called post-training. It's basically fine-tuning the AI on these gigantic specialized sets of data. But here's the problem. Finding or creating enough of that high-quality, really diverse data is a huge roadblock. It's super expensive, it takes forever, and honestly, it's just incredibly hard to do right.
And here's where it gets really interesting. The problem isn't just the sheer amount of data. It turns out we've been measuring its diversity all wrong. Like, completely wrong.
For a long time, when we said data diversity, we were really just looking at surface-level stuff, things like word choice, sentence structure, syntax. But this research makes it crystal clear that those things have almost zero connection to how well the AI actually performs. We were basically judging a book by its cover, and it wasn't working. We were measuring the wrong thing.
So, if just looking at the text isn't the answer, then what is? Well, the researchers had a brilliant idea. They decided to stop looking at the data from the outside and instead peek directly into the AI's brain to see what it was actually learning.
And this brings us to this really cool concept called a feature. A feature is basically a single understandable concept that the AI has learned to recognize. The best way to think about it is like a single neuron in its brain that lights up whenever it sees a super specific idea, whether that's a topic, an emotion, or even just a style of writing. And this is what they actually look like in the real world. For an AI trying to detect toxic content, you might have feature 2039, which fires up for ideas about robbery, or feature 176112, which is all about cheating on tests. Yeah, both of those are pretty relevant. But then you get something like feature 4647, which just activates for the word according. Not exactly helpful, is it? So once you can identify these individual features, you can get way smarter. You can build a system to create smart data, not just big data. And that's exactly what this new system, the FAC synthesis framework, is all about.
And it works in 3 pretty simple steps. First, you use this special tool, it's kind of like an AI brain scanner, called a sparse autoencoder, to map out every single concept the AI already gets. Step 2, you figure out which important concepts are missing. And finally, step 3, you use another AI to generate brand new data that is specifically designed to teach the AI those missing pieces. It's like creating a personalized study guide for the AI to fill in its knowledge gaps.
This diagram here shows you the whole thing in action. So over on the left, you've got the AI's existing knowledge, right? The system then identifies the gaps. Those are the missing features you see in the middle. And then it tells a generator on the right exactly what kind of data to create to perfectly fill in those gaps. It's a beautifully targeted process. Okay, so the theory is cool, but does this actually work in practice? Well, the results are, and I'm not exaggerating here, pretty astonishing. This is the big one. This new FAC synthesis method, it reached the same top-tier performance as the old way with just 2,000 data samples. The previous best method needed 300,000 samples to do the same thing. That is 150 times less data for the exact same result. Just wow. And here's the proof in the pudding. This chart shows a nearly perfect positive correlation, a Pearson score of 0.95, which is incredibly high, between how many of these features you cover and how well the AI actually performs. It confirms that this isn't just some random new metric. It's a fantastic predictor of success. Plain and simple, the more concepts you teach the AI, the better it gets. Look, this is so much more than just a clever lab experiment. This could fundamentally change the economics, the strategy, the whole game of building powerful AI. The implications here are just huge. I mean, training could become dramatically cheaper and faster. We can make AI safer by specifically telling it which concepts to focus on or which ones to avoid. And maybe the wildest part is that many of these features are shared across different AI models. That means we could literally transfer knowledge from one AI to another, building a library of concepts to make all our models smarter. As the authors themselves put it, this whole thing provides a really solid, practical way forward. It shifts our focus from just building bigger and bigger models to curating better, smarter data.
And that really leaves us with this final, powerful question. If the biggest barrier to creating powerful, specialized AI is no longer a massive mountain of data, but a smart, targeted process, what new frontiers can we explore? What problems that were once just too big or too niche for us to even try to solve are now suddenly within our reach?